Science is this incredible journey of discovery, right? But you can think of it like a super high-speed highway. And any highway needs guardrails, not to slow things down, but to make sure that whole pursuit of knowledge doesn't just veer off into some really dangerous territory. So today, we're going to explore the ethical framework that keeps science on the straight and narrow and keeps it trustworthy.
I mean, just think about that for a second. It's a pretty chilling thought, isn't it? Every single piece of technology in your pocket, every medicine you might take, it's all built on a foundation of scientific trust. But what happens when that foundation starts to crack? And that's the really scary part. It doesn't take some massive conspiracy. No. All it takes is one researcher, one fudged number, to poison the entire well of knowledge. And that can create these ripples of doubt that last for years and years. And that is exactly why we need a strong ethical framework. This isn't about creating a bunch of red tape for scientists. It's about safeguarding all of us, the public, and protecting the very integrity of knowledge itself. So what are these guardrails really for? Well, they're the system that makes sure a scientific fact is, well, an actual fact, something that's been rigorously tested and verified. They're there to stop fraud in its tracks, to protect the work of honest scientists, and to make sure that credit goes where credit is due. Honestly, this is the bedrock of all scientific progress. Okay, so if those are the rules of the road, what about the personal code? The principles that every scientist is expected to live and breathe. Let's dig into the core virtues that make for a truly trustworthy researcher. And look, these are not just some abstract words you hang on a poster in the lab. We're talking about active virtues. Honesty when you report your data. Objectivity when you analyze it. Integrity in your methods. And, crucially, an openness to being proven wrong. This is the moral compass that guides a researcher's hand when absolutely no one else is in the room.
But what happens when that moral compass breaks? Yeah, let's turn to the dark side of research for a minute. The ethical violations that don't just derail science, they can absolutely shatter public trust. You could call these the cardinal sins of the scientific world. This covers a whole range of things, from plagiarism, which, by the way, doesn't just steal credit, it actually corrupts the historical record of a discovery, all the way to nasty fights over who gets their name on a paper. But two of the absolute worst sins are fabricating data from nothing, and its more subtle and maybe more dangerous cousin, falsification. Now, falsification is so insidious because it's not a complete lie. It's taking real data and just twisting it. It's cherry-picking the results that look good, subtly tweaking an image or just nudging the data points enough to make a really weak finding look like some kind of massive breakthrough. And here's the danger in a nutshell. On the left, you've got an honest, maybe a little underwhelming result. Fine. On the right, you have a dangerous lie dressed up as the truth. That tiny change could be the difference between a useless drug getting approved or a harmful new therapy being rolled out to thousands of people. This isn't just academic. We're talking potential life or death consequences. And it can be so deceptively simple. Imagine a researcher. Maybe they're feeling that immense publish or perish pressure we hear so much about. So they just slightly enhance an image to make a result look a bit cleaner, a bit more convincing. It seems like a tiny thing, but it's a deliberate deception. It poisons the well for every single scientist who comes after them. So how do we stop this from happening? How do honest researchers navigate all these pressures and make sure they stay on the right side of that ethical line? Well, thankfully, there's a pretty clear playbook for how to maintain integrity. And this brings us right back to those core virtues we talked about, but now they're direct commands. Report your data truthfully, not hopefully. Be transparent about any potential conflicts, like who's funding your study. Give credit where it's due. Seriously, these aren't just polite suggestions. They are the non-negotiables of ethical science. But that's the million-dollar question, right? It's one thing to know the principles, but how do you actually apply them day in and day out, in the messy reality of a lab, with a deadline looming? What does that actually look like in practice? It really boils down to these 5 critical steps. Think of it like a pre-flight checklist for scientific integrity. 1. Cite every single source you use. 2. Know the specific ethical rules of the journal you're submitting to. 3. Report what you actually found, not what you hoped you'd find. 4. Be totally transparent about your funding. And 5. Be generous and fair when deciding who gets credit as an author. But a scientist's individual integrity isn't the only line of defense here. Science has this incredibly powerful built-in quality control system. It's designed to catch errors, sloppiness, and even outright fraud before it gets published. It's time to meet the gatekeepers. The whole process is called peer review. Before any study gets published in a reputable journal, it's sent out to other anonymous experts in the exact same field. These experts act like detectives. They check the methods, they scrutinize the results, and they judge if the work is sound, if it's original, and if it's actually important. It's basically the ultimate stress test for any new scientific claim. And guess what? Just like the researchers, these peer reviewers have their own strict code of conduct. They have to maintain total confidentiality. They have to be completely objective. No personal rivalries allowed. They have to provide feedback quickly, and their comments have to be constructive. Their job is to help strengthen science, not just tear it down. So let's bring it all back home. From one scientist's personal integrity all the way to the anonymous diligence of a peer reviewer, this whole ethical framework is what allows us to trust the very label of science. It's the system that helps ensure the medicines we take are safe and that the knowledge we build our entire world on is solid. Which, leaves us with one final thought. This isn't just a conversation for scientists. As people who live in a world completely shaped by science, we all have a stake in this. By demanding transparency, by questioning extraordinary claims, and by supporting the institutions that champion integrity, we all play a part in reinforcing those guardrails. So, I'll leave you with this. What do you think is the most important guardrail of all? Thanks for joining us.